Alright, here we go. 3.7. Factoring a sum or difference of cubes. Alright, let's see. Using example, we're going to factor x cubed minus 8 completely. Doing it the old way, we would have found the possible factors of 8 are plus or minus 1, 2, 4, and 8. So we plug in 2, and 2, and if we plug in 2 here, 2 cubed minus 8 gives us 0. So that means x minus 2 is our factor. We get rid of the x, alright, and we take negative 2 and we plug it into 1, 0, 0, 8, negative 8. Some of you are wondering, why is that the case? Well, don't forget, this is a cubic function, and there should be 4 terms. The other 2 terms are zeros, so that's what we're writing here. And now we use synthetic division to get our answer. We know that the remainder is going to be 0, therefore x minus 2 is a factor. What does that leave us? Well, it leaves us with the factors x squared plus 2x plus 4. Because x minus 2 is our factor, so we factored it out, and we're left with x squared plus 2x plus 4. Well, some of you are wondering, well, can't that be factored? And the answer is no, because what 2 numbers multiplied by 4 add to give us 2? Hopefully, all of you are racking your brains and realizing it's not possible. It is not possible to factor this. So this is the final factors for x cubed minus 8. Let's develop a general formula. The general formula is as follows. Whether you have a sum or a difference of cubes, the rule applies as follows. If you have a cubed minus b cubed, the cube root of a cubed is a minus b times a squared plus ab plus b squared. So, I want you to understand that this is the factor of this. This is how you factor it, and you cannot factor the second bracket any more than this. So, you take the cube root of each term, a minus b. For the second part, it's what's left. A squared is left, plus ab. The reason the plus ab is here is when I expand this, I'm going to have an ab. You need the ab to disappear. And then you have plus b squared. If it's a minus here, it will be a plus here. Let's look at it when there's a plus in the middle. So a sum of cubes. You're going to have the following. What is this? Well, a plus b, just like in this question was a cubed minus b cubed, this one is a cubed plus b cubed. So a plus b times a squared minus ab plus b squared. So that's what you're going to end up with. We need to be able to factor sum and difference of cubes instantaneously. So let's look at example number 2. Factor completely 64x cubed minus 27y cubed and 5x to the power of 4 minus 625 to the power of x. For the first one, we rewrite that statement as a difference of cubes. There we go. And once we do that, we can factor it. You have 4x minus 3y times 4x all squared plus 4x times 3y plus 3y all squared. Simplifying that expression, you end up with 4x minus 3y times 16x squared plus 12xy plus 9y squared. Do the same for the second one, but hopefully you're all wondering what to do now because I have x to the power of 4. Well, here it is, folks. You take out an x and you take out a 5. You take out both of those because those are common factors. Remember, the main rule about common factors is you must common factor first. And that's what's going on here. Common factor happened, and then you now have a sum of cubes. So you can factor it, x plus 5 times x squared minus 5x plus 25. Alright, let's try another one. Part C. x to the 6 minus 64. This is a difference of cubes. It will be x squared all cubed minus 4 all cubed. So now we can use the difference of cubes rule. There's the difference. But lo and behold, guys, this is not the end of it. This is not the final answer. Why? Because this is continuously factorable. X squared minus 4 can be factored into x minus 2, x plus 2, and then the remainder, and the remaining stuff. Not the remainder, but the remaining part. Okay. Well, let's try one more, folks, and see where we're going with this. Here's one. What do we do with a question like this, with fractions? Well, convert the fractions to cubes, and we have this, the second fraction, to 2 over 5, all cubed. And now what we can do is factor this like it's a sum of cubes. So, sum of cubes says that it has to be 1/3 x plus 2/5 times 1/3 x all squared minus 1/3 x times 2/5 plus 2/5 squared. So our final result will be 1/9 x squared, or x squared over 9, minus 2 over 15x plus 4 over 25. Alright, folks, that's the end of the examples. Hopefully you looked at sum and difference of cubes and you're able to do it. Take care. Have a good night.